Here and resistance is taken, and this is the source. It is a AC source. The voltage is how much? The Vm sin omega t. Okay, so we have applied a voltage Vm sin omega t. Now R is the resistance. Now let I current is flowing through this one. So what is the voltage value? V is equal to IR, or we can say that I is equal to Vm by R. Okay, so V by R. So what is V? Vm sin omega t. So it is Vm by R sin omega t. Okay, so this current equation will be this one, this equation 2. We can see here. Equation 2, that is I is equal to Vm by R sin omega t. Also a purely sinusoidal wave, sine wave is, and the phase is same as the voltage, because here it is sin omega t and here also it is sin omega t. Here its maximum magnitude is Vm, but here its current's maximum magnitude is Vm by R. So here current is Vm by R. So we can see this is dotted line is representing the current, and this magnitude, highest magnitude is Im. That is how much? That is Vm by R. Okay, so in a purely resistive circuit, the current magnitude will be equal to Vm by R, and it will follow the same phase as the voltage. Okay, so this is the thing. Now what will be the power? The instantaneous power, or a particular power at a particular time, that is V into I. So V is what? Vm sin omega t. I is Im sin omega t. So if you will multiply V into I, that is Vm Im sin square omega t. Okay, so sin square omega t is how much? Sin square omega t is equal to 1 minus cos 2 omega t by 2. So this will can be written as like this. So this by 2, this 2 can be divided among these two, like here we can write down root over 2 into root over 2. So I am by 2 can be written as I am by root 2 and Vm by root 2. So this is the RMS value and of voltage, and this is the RMS value of the current. So in this way, you can see the total power or average power is equal to Vm by root 2 into Im by root 2, or we can simply write down Vrms into Irms is equal to your total power. Okay, where the cost value goes for average value, cost factor will be equal to 0. So that part will goes to 0. Only this constant part will remain, that is this one. Okay, so for if you are taking the average power, that is this one, that is V into I, Vrms into Irms. And if instantaneous power you have to take in, then you have to take all the things. This is the instantaneous power. Instantaneous power means power at a particular time. It is the power. And what is the total average power from this point to this point? That is equal to this much. Okay. So if now you will see what is the power waveform. This power waveform you can see. This is the multiplication of I into V into I. So at each point you have to multiply both the voltage and current. So you will get a waveform like this. Okay. So that means you are getting a sinusoidal waveform, but in the positive half side, positive direction. No negative values is there. Okay. So here you can see this is the constant value, that is Im by Vm Im by root 2, and a sinusoidal value of magnitude Im by Vm by 2 is the maximum of this sinusoidal waveform. Here you can see that. Okay, already this thing I have explained in the board in the class. So easily you remember that if you will read this one. Okay, so this is the total power for a purely resistive load. Now next come to the purely inductive load. So here this is the purely inductive load. We have taken inductance and this is the voltage supply. Vm sine omega t is the value of the voltage and L is the inductance value. Let I current is flowing through this one. Okay, so if I is flowing, then what will be the current voltage across this? That is VL. So VL will lead the current like this, 90 degree. Okay, so we will see here how it is happens. Now see, V is equal to, what is the formula for the inductance? V is equal to L di by dt. V is equal to L di by dt. So put this, if we will find out I, then what will be the equation for that one? That is Vm by L sine omega t integration of sine omega t dt. So here sine omega t integration, that will come cos omega t 1 by omega. So here you will get Vm by omega L cos omega t. Okay, so Vm by omega L sine cos omega t can be converted into sine, that will be sine omega t minus pi by 2. So here this is the maximum value we can take and this is the sine function and here minus pi by 2 is there. So from this we can say the current is lagging to the voltage by pi by 2. If it is the voltage is the reference, then the current will lag by pi by 2, 90 degree lagging. Okay. So what is the maximum value of the current? That is Vm by omega L. And omega L is what? That is the reactance of the inductor. So Vm by XL we can find out. XL is the reactance, omega L. Now, if you will take the voltage waveforms, this is the voltage waveform. It is the reference one, and this is dotted line is the current waveform. It is lag to the voltage by pi by 2 degree. Okay, and its magnitude, highest magnitude is equal to Vm by omega L. That can be written as Im. Okay, now what will be the power? So here the power, instantaneous power will be your V into I. So V m sin omega t into I m sin omega t minus pi by 2. Okay, so Vm Im into sin omega t into sin omega t minus pi by 2 equal to Vm Im sin omega t into cos omega t. So that if you will see, this is the instantaneous power. Okay, sine 2 omega t. Vm Im by 2 sine 2 omega t is the instantaneous power. So what will be the average power? If you will take the average, here you can say this is a sinusoidal, purely sinusoidal, sine only, no constant part is there. So if you will take the average, that will be 0 because it is the sinusoidal and integration of mean of that will be becomes 0. So the average power for an inductor is 0. Okay. So this diagram for the power is also given here. From this point to this point, that means from 0 to pi by 2, this voltage value is positive, but current is negative. Current is negative. So we are getting a negative power. Positive into negative, we are getting negative power. And from pi by 2 to pi, that voltage is positive and current is also positive. So that means we are getting a positive power. Similarly here, from pi to 3 pi by 4 is equal 3 pi by 2 is equal, this is also negative. Here current is positive but voltage is negative, so here you will get negative power. Again here positive. So negative, positive, negative, positive. If you get the average, then that will be equal to 0. Okay. Similarly, now we can go for the capacitor. So this is your capacitor. So now see, here this voltage source is applied to a purely capacitor. Here this current is going through this capacitor. Okay, and we have applied the voltage is equal to Vm sin omega t. So what will be the current? Current is equal to d C into d V by dt. So here C Vm sin omega t derivative you have to find out. So you can see it is C Vm cos omega t. Okay. So here I is equal to Vm by 1 by omega c cos omega t. Or we can write down Vm by 1 by omega c into sin omega t plus pi by 2. Okay, so here we are getting I is equal to Im sin omega t plus pi by 2. So here we are getting plus pi by 2 means it is leading. Here the current is leading the voltage. So here you can see this is the voltage phasor. It is the reference. The current will be leading by 90 degree here. Okay. Here the phase difference is positive pi by 2. Then again, if you will go for the power, then you have to again find out instantaneous power, that is V into I. So V is equal to Vm sin omega t and I is equal to Im sin omega t plus pi by 2. Okay. So now again putting multiplying these two things, we can see it is again sinusoidal waveform. Vm Im by 2 sin 2 omega t. So sin 2 omega t average is equal to 0. So the total average power for the capacitor is also 0. But instantaneous power, if you will see, you can see this power waveform will be like this. From 0 to pi 2, that is positive, and from pi by 2 to pi it is negative. Similarly, it is positive here and it is negative here. So here we can say the total average power is 0. But what is the instantaneous power? That is equal to Vm Im by 2 sin 2 omega t. Okay. So it is the pure resistive, pure inductive and pure capacitive circuits we have completed. Now next we will go for the combinations. That is the chapter number 13. Okay. So here you can start from here. Resistive and inductive circuit. Resistance and inductance is in series. Okay, with the voltage source. So here this V voltage is applied to a resistance and an inductance. So here it is a series circuit. So we let us say this voltage across the resistance is VR and voltage across the inductance is VL. Okay, and from the individual elements we can see the current flowing through this is in phase with the voltage. So that means if I current is flowing through this, then voltage VR is in the same phase with the current, and in this VL is the 90-degree leading to the current. Okay, so if you will draw the phasor for the voltages, now see if it is the reference current direction, because current is same for this, so we can take it as reference. And what will be the VR? VR is in the same direction of the current. This is VR. And what is VL? That is 90-degree leading to this current direction. So that is in this direction. So this is VR and this is VL. So what is the addition of these two? That is the supply voltage. So if we will add these two voltages in vector form, that it is the V. It is the voltage what we have supplied to this one. So V is equal to VR plus VL in vector form. Okay. So here you can see VR is equal to IR, voltage drop across the R. VL is equal to I into XL. XL is what? Omega L. XL is equal to omega L. Okay. So in this way, you can find out the V. V is what? V is the vector addition of these two. That is VR square plus VL square is equal to V square. So V is equal to root over VR square plus VL square. So VR square plus 1 in I into XL square. Okay, so I, if you will come taken outside of the equation, then that is I into root over R square plus XL square. Okay.